Today we're going to look at section 1.5. Topic is equations. If you want to look this up in your textbook, we're looking at page 45. So the first thing we're going to look at is an example. 4x plus 7 equals 19. So this is an equation, the equality of two algebraic expressions. So this is an equation. There's an equal sign, so you're setting those two algebraic expressions equal to each other. The values for x that make up a true statement is called the solutions or roots. So this is the value for x, so what x is equal to, which makes it a true statement. The process for finding this solution or root is called solving the equation. So now we're going to look at an example. So to solve an equation, we're going to look at this equation first. 7x minus 4 equals 3x plus 8. So we've got the equation with the equal sign and the equality of two different expressions. So now we're looking at getting all the x's to one side and all the constant terms, the ones that don't have x's, to the other side. So I'm going to take a negative 3x to both sides. Now I've got all the x's on the left-hand side, so now I need to get the 4 over to the right-hand side, so I'm going to add 4. So this adds to be 0, this adds to be 0. 7x minus 3x, combining like terms, is 4x equals 12. So then we divide by 4 on both sides. We get x equals 3. Now you can check to see if 3 works by taking x equals to 3 and plugging it back into the original equation. Now another thing we do with equations is solving for a specific variable. So solve the equation for a specific variable. So we're going to start out with one example that looks like f equals g lowercase m capital M over r squared. Now that's an equation. So we've got the equation, the equal sign between them. But now we're going to tell what variable we're going to solve for. So we're going to solve for capital M. So what that means is I want capital M on a side by itself. So we're going to rewrite f equals g lowercase m capital M over r squared. So we're trying to get rid of everything on this side except for the m. So if I'm dividing by r squared, I can multiply by r squared on both sides, and that will cause the r squareds to cancel out. But also the g and the lowercase m are in the numerator, the top of a fraction. So to get it to go away, I have to put the capital G lowercase m in the denominator. So the same thing over here, I have a capital G lowercase m. So the g and the m divides to be 1. The r squared and the r squared divides to be 1. And I'm left with capital M equals f r squared over gm. Solving for a specific variable. Okay, we're going to give everybody a chance to catch up to that point first. Okay, we're going to look at another example. We have A equals 2LW plus 2WH plus 2LH. Now, just as a side note, if I look at a rectangular box, and so I'm going to dot this part in as if it's in the back. So this rectangular box, this would be my length, width, and height. So if I take h times w, that would be this side and this side, that would give me 2h times w, which I have a 2hw right here. Same thing, 2lh, so I have 2lh would be this side and the back side, and then L and W for the top, to the top and the bottom. So this actually is the formula for the surface area of a rectangular box. So now we're going to solve this one for W. So we're looking for all the ones that have W's in them, so we're going to circle the W's. So I'm going to start out with A equals 2LW plus 2WH plus 2LH. So I'm trying to get all the W's on one side and all the non-W things on the other side. So I'm going to take a minus 2LH minus 2LH. So that cancels out to be 0. Subtract in a positive. So I get A minus 2LH equals. Now on these two, we can see that there's a W in common to both of them. There's actually a 2 and a W. But since we're solving for W, we're just going to distribute the W out. So if I take a W out of this one, I get 2L. Take a W out of this one, I get 2H. So I'm solving for W, so I'm going to, this is multiplied, so I'm going to divide both sides by 2L plus 2H. So these two cancel out. So I have W equals A minus 2LH divided by 2L plus 2H. So here is the solving for W. So the next thing we're going to look at is solving a quadratic equation. Now the ones that we did before were, if we look at that original one, it was to the first power, so that would have been a linear equation. So this quadratic equation is going to say of the form ax squared plus bx plus c equals 0, where a cannot be 0. Now, let's ask the question here. Solving a quadratic equation of this form, why do we have to say a cannot be 0? Well, if a was 0, then that x squared term would go away and we'd be left with an x to the first term, so that it would be a linear, not a quadratic. So the a has to be not be 0, it has to be there to be a quadratic. So for an example, we're going to have x squared plus 5x equals 24. And we're going to solve by factoring. Now, to be able to get it into this form, we have to get this 24 over to the left-hand side. So we're going to minus 24 to both sides. So that gives me x squared plus 5x minus 24 equals 0. So now we're going to factor. So solving by factoring means that I'm going to take this and put it into two sets of parentheses. So it's like FOIL in reverse. First ones times each other has to be our first term. So that means x and x. The 24, we're looking for factors of 24, things that multiply to be 24 but subtract to be 5. So we know we're going to have an 8 and a 3. So 8 minus 3 gives me 5, but now I have to decide which one's positive and which one's negative. So I know in this case, subtract and take the sign of large is going to make the 8 positive and the 3 negative. So now we have two things multiplied to be 0. So now we're going to use what we call the zero product rule. So zero product rule means if two things are multiplied, the word product is talking about multiplication. Two things multiply to be 0, then we know that at least one of them has to be 0. So x plus 8 could be 0, or x minus 3 could be 0 to make this product to be 0. So minus 8 gives us x equals negative 8, plus 3, x equals positive 3. So you can check them by plugging them back in to see if they work, and then we'll have x equals negative 8 and 3, which would be called our solution set. Okay, we're going to give everybody a minute to get that to that point. So again, we're going to do a quadratic, but a different form of a quadratic. This one is going to solve by square root method. So we have x minus 4 squared equals 5. So we have quadratic because we've got a squared term. So we're trying to solve for x, so we want this x minus 4 squared, the squared to go away, so I'm going to take the square root on both sides. Now when I take the square root on this side, the square root of something squared is just going to give me the x minus 4. But on this side, when we take the square root on both sides, it's going to be plus and minus square root of 5. Because negative times negative is positive, and positive times positive is positive. So now we take and we add 4 to both sides. And you get x equals 4 plus and minus the square root of 5. Now you can write this also separately as two separate terms. So I get x equals x plus 4 plus square root of 5, 4 minus square root of 5. And this would be my solution set then. 4 plus square root of 5, 4 minus square root of 5. The next one we're going to look at is solving by completing the square. Now, completing the square is a concept that we're going to use in a lot of things, so it's important for us to know the steps. So we're going to start out ax squared plus bx plus c equals 0. So we need to get one side equal to 0. So we're going to start out with an example, 3x squared minus 12x plus 6 equals 0. So we're going to do the different steps. The first step is to move c to the other side. C is the constant term, so move c to the other side. So minus 6 minus 6. The next thing we're going to do for the second step is to distribute out the a. So we're going to get the a to distribute out. So I'm going to have a 3 come out and give me x squared minus 4x equals 0. Now, by the name, it says that we are completing the square. So we're trying to make this side come out to be a perfect square. So what we're going to do next is we're going to look at the a. We already took it out. Okay. Now we're going to take half of b and square it. So our b now becomes the negative 4. So we're going to take half of b and square it. So that would be our third step. Take half of b and square your answer. So we're going to take half of negative 4 squared. Half of negative 4 would be negative 2. Negative 2 squared is 4. And then we're going to add that 4 inside the parentheses. So add 4 inside parentheses. So now what we have to check into, we can't just add arbitrarily a number on one side of the equal sign. We have to add something on the other side of the equal sign to make up for it. So what we did was we really added 3 times 4, which was 12. So 3 times 4 being 12 means that now I'm going to take a minus 12 to both sides. We've added 12 on this side, so now we're going to add 12 on this side. So whatever I did on this side, I have to do on this side. So 3 times 4 gave me 12 that I added here, so now I'm going to add 12 over here. So I have 3x squared minus 4x plus 4, and negative 6 plus 12 gives me a 6. So now from this point, I'm going to finish it out by doing the 3. So what do I do to get rid of the 3? I have to divide by 3 on both sides. So take half of b, add 4 inside the parentheses. So then next step we're going to do is divide by the 3. So this cancels out and gives me x squared minus 4x plus 4. And this gives me 2. But when we say completing the square, now we're going to have this be a perfect square. So I get x and x. 2 times 2 gives me 2, but since it's positive, they're either both positive or both negative. So I'm going to have minus 2, minus 2. Always check your middle term. Negative 2x and a negative 2x gives me negative 4x. So now I have x minus 2 squared equals 2. So we factored. But if we look back at what we did up here, we did square root methods. So that's what we're going to do for the rest of it here. So we're going to solve. Square root on both sides gives me x minus 2. Square root of something squared, plus and minus the square root of 2. So I add 2 to both sides. And my answer then gives me x equals 2 plus and minus the square root of 2. So completing the square. Now we're going to do the same problem, but we're going to do it by a different method. So that was by completing the square on a quadratic that had an a. So again, we're going to do the same thing, but on this one, we're going to solve using the quadratic formula. Now we're going to be starting out with ax squared plus bx plus c equals 0. Now we're not going to go through the process, but if I did completing the square on this with using the a, b, and the c instead of putting numbers in, then I would come up with x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So this is what we call the quadratic formula. So quadratic formula is found by completing the square on the ax squared plus bx plus c equals 0. So from our previous example, we've got 3x squared minus 12x plus 6 equals 0. So ax squared plus bx plus c equals 0. So our a is going to be 3, our b is going to be negative 12, our c is going to be 6, and then we plug it into the formula. So I have x equals negative b, but we said our b was a negative 12. B squared is going to give me negative 12 squared minus 4 times a is 3, c is 6, all over 2 times a, which is 3. So now we simplify all of this. So that gives me x equals negative times negative would give me a positive 12 plus and minus the square root. Negative 12 times negative 12, because that's what squared means, is going to give me 144. 4 times 3 is 12, times 6 is going to give me 12 times 6 is 72. So I'm going to have a minus 72. All over 2 times 3 is 6. So now we subtract 144 minus 72, so I get x equals 12 plus and minus the square root of 72 over 6. But now we have to do something with that square root of 72. We have to simplify it. So I've got 12 plus and minus the square root of 36 times 2. So what I was looking for to find the 72 is to break it into two factors where one of them is a perfect square root. So now I've got x equals 12 plus and minus. Square root of 36 is going to come out as 6. And then the square root of 2 is going to stay inside, all over 6. But now you can see that the 6 can come out of both of these. So we're going to distribute a 6 out, which would give me 6 coming out of 12, would give me 2, plus and minus square root of 2 over 6. But since that's multiplied, I can cancel that 6 with this 6, divide out to be 1. So I get x equals 2 plus and minus square root of 2, which is the same answer we got before. So give everybody a chance to catch up to that point. The next thing we're going to look at is the discriminant. The discriminant tells us how many real solutions that your solution set is going to have. Now, if I look at ax squared plus bx plus c equals 0, x equaling negative b plus and minus the square root of b squared minus 4ac all over 2a. We said this was the quadratic formula. So in order to use what we call the discriminant, we're going to take the radicand, the part that's under the radical, and call that the discriminant. So if we look at the discriminant, the b squared minus 4ac discriminant, it comes from like the word discriminate, so to see differences. So this is going to tell us the differences. So if I have d greater than 0, d meaning the discriminant, b squared minus 4ac. If it's greater than 0, then I'm going to have a perfect, not a perfect square root, but a square root, plus 1 and a minus 1, like we did on the previous example. We had 2 plus square root of 2, 2 minus square root of 2. So if d, the discriminant, is greater than 0, then we're going to have 2 real solutions. If I have d equal to 0, d equals to 0 is going to make that whole term go away, and the plus and minus is going to go away with it, and we just have the negative b over 2a. So this one's going to have one real solution. Remember again, we said that funny R stands for real number. If I have d less than 0, means that this is going to be a negative number. Now, we haven't talked about imaginary numbers yet, but this is not going to be a real number this time. So we're going to have no real solution. So when we look at this for the discriminant, if we look at our previous problem, we have 3x squared minus 12x plus 6 equals 0. So I'm going to do just the discriminant part. The discriminant's going to be the b squared minus 4ac. So we're going to have the discriminant is going to be negative 12 squared minus 4 times 3 times 6. And we said this was 144 minus 12 times 6, 72, which gave us 72. So if the discriminant is equal to 72, that 72 is a positive number. So that would be d greater than 0. So we would have two real solutions. And if you look back on what you got, again, we did get 2. We got 2 plus square root of 2, 2 minus square root of 2 would be our two solutions. So discriminant just tells us what kind and how many. Okay, the next one we're going to look at is solving a rational equation. Okay, solving a rational equation now. So we're going to have involving rational expressions. So 3 over x, 2 over x minus 3 equals negative 12 over x squared minus 9. So we have an equal sign, so we have an equation. We have rational expressions because we have a numerator and the denominators. So now we're going to look and see if we can find the common denominator. The denominator is the bottom of the fraction. So I'm going to factor this one, the difference of two squares, x and x, 3 and 3. Since it's a negative 9, one's got to be positive and one's got to be negative. So you can see that on this one, we're going to need an x, we're going to need an x minus 3, and we're also going to need an x plus 3. So we're going to multiply both sides by the common denominator, which is x, x minus 3, x plus 3. So we're going to have to do it on this side too. X times x minus 3, x plus 3. So when I put this over 1, as long as I multiply the same thing on both sides of an equation, it's still going to be equal. So on this side, we can see that it's going to cancel. The x plus 3 is going to divide out with the x plus 3. The x minus 3 is going to cancel out with the x minus 3. And we're left on this side with negative 12x. This side, we're going to have distributive property. So the first one's times each other, the x cancels, and you're left with 3 times x minus 3, x plus 3. Because the x is canceled. And when I multiply this times this, you're going to get minus 2. But the x minus 3 is canceled, so x times x plus 3. So everybody okay to that point? So the next thing we're going to do is we're going to simplify this term and this term. So this term on this side, we're going to FOIL. So I'm going to get 3 And this is going to give me FOIL, x squared plus 3x minus 9. This one, we're going to distribute the negative 2x inside. So that's going to give me minus 2x squared minus 6x equals negative 12x. So now negative 3x and a positive 3x cancel. So now this is distributive property again. So that gives me 3x squared minus 3 times a negative 9 is 27. Minus 2x squared minus 6x equals a negative 12. Now I want to get everything to the left-hand side. So I'm going to take a plus 12 to both sides. 12x. So I have 3x squared minus 2x squared gives me 1x squared. I've got a negative 6 and I've got a positive 12. So that's going to give me plus 6x. And this cancels to be 0. And so I have minus 27 equals 0. So x squared plus 6x minus 27 is combining like terms. So now I factor this into two sets of parentheses because we're solving for x and x. So now we're looking at factors of 27 because it's negative that subtract to be 6. So we know two things that multiply to be 27 are going to be 9 times 3 that subtract to be 6. But the 6 is the positive one, so the rule says subtract and take the sign of the larger. So the larger number has to be the positive. So what did we call this? We called this now to solve using zero product rule. So I have x plus 9 equals 0, x minus 3 equals 0. So minus 9 gives me x equals negative 9 plus 3, x equals 3. So the next thing that we got to look at is, because now we have fractions or rational expression, we have to decide x minus 9, x plus 3. Do both of those things make a true statement? So if I plug into the positive 3 into the denominators, positive 3 here is fine. But when I put a positive 3 into here, what happens to that x minus 3? Well, that x minus 3 becomes 0. So we know we can't have 0 in the bottom of a fraction. So the 3 does not work. We have to exit out. So you can't have 0 in the bottom of a fraction. So if I put in the negative 9, it works for that to not have a 0. So our solution set then, checking for restrictions, is x equals negative 9. So be very careful when you have a rational equation to make sure you go back and check and see what you get. Okay, the next one we're going to look at is solving an equation with a radical. Solving an equation with a radical. So we have 2x minus 1 equals negative square root of 2 minus x. So the radical we want to get rid of the radical on both sides. So this one's going to give us negative. So when we square both sides, negative times negative is to become positive anyway. So we're going to square both sides. So this side gives me 2x minus 1 times 2x minus 1. This one gives me negative times negative is positive. Square root of something squared is just going to give me 2 minus x. So the negative times negative made it come down as a positive. So now we're going to do FOIL. two sets here of parentheses. First times each other, 4x squared. Outside minus 2x, inside minus 2x. So that gives me minus 4x. Negative times negative gives me a positive 1. So now we want to get everything on the same side. So I'm going to take a minus 2 and a plus x. So this gives me 4x squared. This is 1x and a negative 4 gives me a negative 3x. 1 minus 2 gives me a negative 1 equals 0. So we have 4x squared minus 3x minus 1. So now this again, we're going to do factoring. So now we look at what kinds of things that we're going to have as factors, because the a is now going to have a 4, so it could either be 2 times 2 or 4 times 1. So we're going to use 4x and 1x and 1 and 1. Since it's a negative 1, we know 1 has to be positive and 1 has to be negative. So this gives me 1x, this gives me 4x, but the negative is the 3, so subtract and take the sign of the larger means this one's going to be my minus and this one's going to be my plus. So using again two things multiplying to be 0, we use 0 product rule. So for 0 product rule, we have 4x plus 1 equals 0, x minus 1 equals 0. So minus 1, 4x equals negative 1, divide 4. Plus 1 gives me x equals 1. So these two divide to be 1. So I get x equals negative 1/4 and x equals 1. So this time you don't have a fraction or a rational number, but you do have a radical. And what do we know about an equation? That when we square the radicals, we might create some extra solutions that are not really solutions. We call these extraneous solutions. So an extraneous solution is something that looks like it's a solution, but it's not really a solution. So we're going to plug the numbers back into our original equation to decide if they're workable solutions or extraneous solutions. So an extraneous solution is one that doesn't work. So I plug in negative 1/4. So I've got 2 times negative 1/4 minus 1. Does that equal negative square roots of 2 minus negative 1/4? So put this over 1. The 2 will cancel with the 4, and that gives me negative 1/2 minus 1. And over here on this side, we have negative square root of negative, and negative makes that positive. So 2 and 1/4. 2 would be 8/4 plus 1/4 is 9/4. So this gives me 2 halves and 1/2 gives me a negative 3 halves. And this negative outside, square root of 9 is 3, square root of 4 is 2. So this one would work. So we know that x minus x equals a negative 1/4 works. But now we got to go back and put the 1 in. So we got 2 times 1 minus 1. Does that equal negative square roots of 2 minus 1? 2 times 2, we have to multiply first before we add or subtract. So 2 minus 1 gives me 1. 2 minus 1 gives me square root of 1 is 1, which would be negative 1. So this one does not work. So x equals 1 does not work. So my solution set is x equals negative 1/4. Give everybody a chance to catch up to that point first. Okay, the next one that we're going to look at is solving absolute value equations. So we're going to look at one that says solving absolute value equations. So the first one we're looking at looks like 2x minus 5 equals 3. So the easiest way on this one is to kind of use a funny saying to help you remember. We're going to use a saying that says drop and sandwich. So drop and sandwich is a method of solving an absolute value equation. So the first thing we're going to do is isolate the absolute value. So first thing is isolate. Now what isolate means is get the absolute value by itself, which in this case it already is. So once it's by itself, then we're going to do the drop and sandwich. We sandwich it between, so we drop the 2x minus 5, sandwich it between that number and its opposite. Now we have to ask ourselves, is this a true or false statement? So if it's true, then we solve as is. If it's false, we separate it into two equations. So is negative 3 equal to positive 3? No, so we know that's false. So we're going to separate it into two different equations. Negative 3 equals 2x minus 5, and 2x minus 5 equals 3. So now we solve these two equations. So plus 5 gives me 2 equals 2x, divide 2, x equals 1. On this side, plus 5 plus 5, 2x equals 8, divide by 2, x equals 4. So my solution set is going to be 1 and 4. You can also go back and always check each one of these to make sure if they work. There's still other ones that are within this section that we would have time to go through, but this gives you a start on this section. If you have questions, then you can let me know. Thank you.